So welcome to today's lesson. In our last lesson, we introduced on lines, the concept of lines. And if you can remember, we said that a point shows a position and it's indicated by a dot and named using uppercase letters. We said if we have 2 points, point A and point B, then we connect the 2 points. What we have is what we call a line segment. So when we join the 2 points showing positions, we get a line segment. If we have 2 lines, we have line A, B, and line C, D. Then these 2 lines do not intersect. They do not meet. If these 2 lines do not meet, then we say that they are parallel. Parallel lines do not intersect. They do not meet or they do not intersect. So we show using the same markings. These 2 markings here show that A, B, and C, D are parallel to each other. So when you're talking about parallel lines, when we are supposed to indicate that line AB is parallel to CD, this is how we write. These two lines mean parallel. You will note that or BA is parallel to DC. If we start with A, AB, then when we are saying it is parallel to CD, then we should also start from this point here. A, B, C, D. If we start from this point, then line BA should also be parallel to line DC. We start from the ends that are corresponding sides or the corresponding ends. They must be going to the same direction. So we are saying if it is parallel, we use these 2 parallel lines to mean AB is parallel to CD. If we have 2 parallel lines and then there is one line that is cutting across the 2 lines, this line is what we call a transversal line. A transversal line is a line that cuts across 2 lines, not necessarily that they are parallel. But if they are parallel, then it is still also called a transversal line. So it is cutting across 2 or more lines. If it cuts through 2 parallel lines like this, you realize that we will come up with angles. So you realize that when we introduce a transversal line, then we have several angles that are being formed. From our last lesson, these two angles, angle A and angle B, are equal. If you can remember from our last lesson, angle A is the same or equal to angle B. Why? When we are supposed to give a reason, they are vertically opposite. Vertically opposite angles. Same case with C and D. They are vertically opposite angles. Then we now have another angle here and D. B and D. B and D, you realize that they are on the same side of the transversal. This is a transversal line cutting across these two parallel lines. You realize if it's cutting through these parallel lines, then we have angles that are formed on this other side. You realize that angle B and angle D are on the same side of the transversal. They are on the same side of the transversal, and you realize that this angle is also at the bottom of this line, and this angle is at the bottom of this line. These two angles are what we call corresponding angles. We call B and D corresponding angles. We also have, if we call this one E, F, G, H. So B and D are corresponding angles. They are on the same side of the transversal line. We also have E, G. These two angles are also corresponding. They are on the same side of the transversal line. EG. They are corresponding angles. They are corresponding angles. We also have other corresponding angles on this other side. We also have other corresponding angles on this other side. Which ones are they? You realize that we have F and H. This side of the transversal line, this is at the bottom of this parallel line with this one. This is also at the bottom. So other corresponding angles are angle F and angle H. Which other corresponding angles do you see? You also realize that angle A and angle C are also corresponding angles. They are also the corresponding angles because you realize that this A is on the same side of the transversal line, and this one is at the top of this line. C is also at the top. So if all of them, if one is at the top, the other corresponding angle should also be at the top of the other line. If it is at the bottom, then it should also be at the bottom, but same side of the transversal line. So we call these angles corresponding angles. Normally, corresponding angles are equal. Normally, corresponding angles are equal. So these angles that you have mentioned here are all equal. These angles are all equal. Now let's look at, so those are corresponding angles. Let's look at alternate angles. So alternate angles normally appear on the opposite side, on the opposite sides of the transversal and inside the other two lines. Alternate angles are on the opposite sides of the transversal and inside the other two lines. Inside the other two lines. So let's see if you can be able to identify alternate angles from this drawing here. So we have said they are on the opposite side of the transversal and inside the other two lines. So if we supposed to find the alternate angle of, for example, F, which angle would be alternate? We are saying they are on the opposite side and they are inside the other two lines. So F, this angle F would be alternate to angle J. It will be alternate to angle J. Because we have said they are on the opposite. This is the transversal. It is on this side. F is on this other side of the transversal. So we look for the angle that is on this opposite side. So the angle that is on the opposite side, and it should be inside the two lines. So you realize that F is inside this line. Then G should also be inside the line. So it is in between the two lines. So F and G are alternate angles. They are alternate angles. What about B? Let's look at identify an angle that is alternate to B. It should be on the opposite side of the transversal line and should be inside the two lines. So you realize that B is inside the line. Oh, the angle that is opposite should be here. And so because this one is at the bottom, so you realize that the angle that is alternate to B is should be angle C. Should be angle C. For you to be able to know that this is alternate, it's that when we have two vertically opposite angles, from the transversal line. So at this line also we'll have vertically opposite angles which are corresponding. So when the other one is at the bottom, the alternate angle should be at the top of the other vertically opposite angles. So we also have, so these are examples of alternate angles. They are on the opposite sides of the transversal and inside the other two lines. So also, alternate angles are also equal. The same case with corresponding angles, alternate angles are also equal. They are also equal, we should note that. So we have learned about vertically opposite angles. We said they are on the opposite side of the vertices. A and B are vertically opposite. C and D, they are also vertically opposite. We also have what we call co-interior angles. What are co-interior angles? These are angles These are angles on the same side of the transversal, and they are inside the other two lines. Same side now. It is the opposite of alternate. So they are on the same side of the transversal, and they are inside. So from here you can see that angle B and angle G, these two angles here are co-interior angles. They are on the same side of the transversal. This is the transversal, same side of the transversal, and they are inside the two lines. Also, F and C, angle F and angle C are also co-interior angles because they are on the same side of the transversal, and they are also inside the two lines. So angle F, angle C are co-interior angles. You should also note that co-interior angles co-interior angles of parallel lines are supplementary. If you can remember from our last lesson, we said supplementary angles add up to 180 degrees. So if we have two co-interior angles, then they should give us, or they should add to 180 degrees. In other words, if we add angle F plus angle C, they should add up to 180 degrees. So if we have two parallel lines, then we have a transversal cutting across the two lines, then we have these angles being formed, angle A, B, C, and D. So we are saying, from what we have just learned, angle A is equals to angle C, which is equals to angle E, and it's also equal to angle G. So let's understand why we are saying that all these angles are equal. Let's start with angle A being equal to angle C. So angle A and angle C are equal because they are vertically opposite angles. They are vertically opposite angles. Angle A and angle E are equal. Angle A, angle E are equal because of, you realize that they are corresponding angles. We said corresponding angles are on the same side of the transversal line, the same side of the transversal line. So A and E are corresponding angles. A and G are equal. A and G are equal. Let's see the reason why angle A and angle G are equal. You realize from the information that we have learned earlier on that angle A and angle G are alternate angles. They are alternate angles. We have said in our last lesson and even previously that vertically opposite angles are equal, corresponding angles are equal, alternate angles are equal. It therefore means that all these angles are equal. It will be the same case with this other angles. B is equals to angle D. Again, you realize that they are vertically opposite angles, B and D. Then B and F. B and F, you realize again, they are corresponding angles. B and H, B and H, these are alternate angles. So again, all of them are equal. Let's now look at an example of how to be able to calculate the values of angles using the information that we have just learned. So let's find, you are told to find the value of the pronumerals. We say these are letters representing the angles. In this diagram, also giving reasons. What is the value of A from what we have just learned? So you realize that here is 120. These two lines are parallel lines, and we have a transversal. So you realize A is on the same side of the transversal with 120 degrees. So these two angles are corresponding angles. So then it follows that A is 120 degrees because they are corresponding angles with 120. B, what do you think is the value of B? You also realize that B is 120. Let's give reason. Why is B 120? Vertically opposite angles. It is vertically opposite angle with 120 degrees. C? So we have our A being 120 degrees. So what will be our C? Our C will be (180 degrees minus 120 degrees. These are angles of a straight line. Angles of a straight line, we said angles of a straight line are supplementary. They are supplementary. So that means C is 60 degrees. That means C is 60 degrees, supplementary angles. So let's find the value of A and the value of B. Let's start with A. What do you think is the value of A? Which angle is this? If we extend this line here, then you realize that this is a transversal line. Then these two lines are parallel lines. They are parallel lines. So you realize that this angle here and this angle here are co-interior. They are co-interior angles. And what do you say about co-interior angles? Co-interior angles, we said, are supplementary. In other words, they add up to 180 degrees. Co-interior angles on parallel lines. So if we add the two, they should give us 180. So for us to be able to get A, we subtract 180 minus 72. So A will be 108 degrees co-interior angle. What about B? How do we calculate the value of B? Again, if we extend this line, If we extend those lines, you realize that we now have two parallel lines. This line and this line is parallel. This line and this line is parallel. We also have this line and this line parallel. So you realize that if this line and this line are parallel, then this will be our transversal. If this is our transversal, this line and this line are parallel, this is transversal, you realize that B and 72 are also cointerior angles. They are cointerior angles found on the same side of the transversal. This time round, this is our transversal. And our parallel lines are this. So again, B and 72 are cointerior. If they are cointerior, we have said they should add up to 180 degrees. So B plus 72 is 180. Then B is also 108 degrees. B is also 180 degrees. Let's look at another example. Let's look at this other example. We are asked to name the angle that is 1 corresponding to angle ABF. So let us identify angle ABF. Angle ABF. It is this angle here. So which angle is corresponding to angle ABF? We said they are on the same side of the transversal line corresponding to ABF. You realize that it is angle BCH. Angle that is corresponding to angle ABF is angle BCH. We are talking about this angle here. Same side of the corresponding of the transversal. Then which angle is corresponding to angle BCG? Angle BCG. This angle here. So you realize that it is angle ABE. Same side of the transversal line. Name the angle that is alternate to angle FBC. FBC. Alternate angles. Alternate angles, we say they are on the opposite sides of the transversal line. So this angle here, FBC, should be corresponding to this angle. It should be alternate to this angle. What do we call this angle? It is angle BCG. Angle BCG. Then an angle that is alternate to CBE. Angle that is alternate to CBE. They are opposite sides. So it will be that one, which is angle BCH. Angle BCH. Let's identify an angle that is cointerior to angle HCB. HCB. Cointerior. The same side of the transversal. So it will be this angle here. So it is angle FBC. Cointerior to angle EBC. Angle EBC. They are talking about this angle here. Cointerior, so it is the same It's that angle there, and we call that angle BCG. 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 So if you are able to identify this correctly, then you have understood alternate, corresponding, and co-interior angles. So let's look at this other example. For each diagram, write the relationship between angle A and angle B. So we have this diagram here, we have A here, then we have B there. What is the relationship? Giving reasons. So the relationship between A and B is that, if you can be able to remember well, A and B are equal. This angle here and this angle here, they are equal. For which reason? The reason is because they are alternate angles. You realize that they are alternate angles. If this are two parallel lines, then this line here is transversal. So the angles that are on the opposite side of the transversal, we call them alternate angles. So A and B are equal because they are alternate angles. Remember, we said alternate angles are equal. Again, let us identify the relationship between A and B, giving reason. So what's the relationship between A and B again? You realize that this is a parallel line with this one, and this is a transversal line. Angles on the opposite sides of the transversal lines are called alternate. Again, alternate angles. Sometimes they can just do this to confuse you. If it's not very clear, you can extend the line so that you can be able to understand that this is a transversal line. So let's look at A again and B. What is the relationship between A and B? A is on, these are two parallel lines. This is our transversal. A and B are on the same side of the transversal. They are then corresponding angles. They are corresponding angles. So A and B are equal because we said previously that corresponding angles are equal. So A and B are also equal because they are corresponding angles. What's the relationship between A and B? The relationship between A and B is A plus B is equals to 180 degrees. Why? Because you realize that these are co-interior angles. These are co-interior angles. You realize that this is a transversal. If it's not very clear, you can extend the lines, and then we can be able to understand well. If we extend the lines, then you realize these two lines are parallel, then we have a transversal. We said the line or the angles that are inside the two lines are on the same side of the transversal are called cointerior angles. So cointerior angles, we said they are supplementary, adding up to 180 degrees. So let's find the value of A and B. Let's start with A. What is the value of A? Again, we are given these two lines are parallel. So we extend for us to be able to understand well. Let's extend those lines. So we have two transversals that are crossing each other. Then they will form angles with the parallel lines. So we have, if we follow this line here, this line and this line are parallel. Then we have this line being the transversal. So this line is our transversal, this is parallel, and this is parallel. You realize that this angle and this angle are on the opposite sides of the transversal, and we call them alternate angles. Meaning, A is equals to 25 degrees. A is equals to 25 degrees. Reason, alternate angles. So A is 25. What about B? Again, we have this parallel line, which is parallel to this. And then we have a transversal here. We have a transversal here. You realize that 30 degrees and B are alternate angles also. You realize they are also alternate angles. So for each, let's look at this example. For each of the diagrams, decide if A, B, and C, D are parallel. So how do we know from the information that we are given that A, B, and C, D are parallel? So we'll use the knowledge of corresponding angles, alternate angles, and cointerior angles. So let's look at this angle and this angle here. What is their relationship? You realize that the angles are on the opposite sides of the transversal line, and they are alternate angles. And we said alternate angles are equal. Alternate angles are equal. For our case, 71 is not equal to 69. So this one, A and B, AB, AB and CD are not parallel. Reason? The reason is because alternate angles are not equal. So you should be able to identify two parallel lines using alternate angles. Check if the alternate angles are equal. If they are equal, the lines are parallel. If they are not equal, the lines are not parallel. So again, let's see if AB, line AB and line CD are parallel. We are given these two angles here. So you should again be able to identify the two angles that we are given. Which angles are these ones? You realize that they are on the same side of the transversal line, which is this one, and they're inside the two lines. What do we call those angles? Co-interior angles. What did we say about co-interior angles? We said co-interior angles are supplementary. In other words, they add up to 180 degrees. So we expect that if these are co-interior angles, then their sum should be equal to 180. So when you add 99 plus 81, it gives us 180 degrees. So what then? What does that mean? It means that these two angles are co-interior. We said we can write AB is parallel to CD using the two parallel lines. AB is parallel to CD, and the reason is co-interior angles are supplementary. The reason is co-interior angles are supplementary. That is a term to mean that the sum of the co-interior angles is equal to 180 degrees. So this you have proved that line AB is parallel to line CD. Again, let us see if A, B, and C, D are parallel lines. So for us to be able to know, again, let us identify the angles that we have been given. Which angles are given here? You realize that this is a transversal cutting through the two lines, and these lines or these angles are on the same side of the transversal. They are corresponding angles. We call them corresponding angles. So corresponding angles, we say they should be equal. Let's check if the two angles are equal. This is 93, this is 97. So the corresponding angles are not equal. So they are not A, B, and C. A, B, and C, D are not parallel because the corresponding angles are not equal. So then you can be able to know whether the two lines are parallel by looking at the corresponding angles, whether they are equal, alternate angles, whether they are equal, or co-interior angles if they are supplementary. So from this information of transversal and parallel lines, we can then move ahead and be able to also learn about the properties of an angle in terms of the properties of a triangle in terms of angles and also the sides. What is a triangle? Let's remind ourselves the meaning or the definition of a triangle. If we can remember well, a triangle is a polygon, which has 3 sides. Triangle is a polygon. A polygon which has 3 sides. So we have different types of triangle depending on the size. We can be able to have different types of triangles depending on the side length. For example, a triangle like this with different markings on each side. Different markings on each side means there is no side that is equal to the other. We are talking about the side. So this has 1 marking, this one has 2 markings, and this one has 3 markings, meaning no side is equal to the other. When we have this type of a triangle, we call it scalene. This triangle here is called a scalene triangle. We also have another a triangle with 2 same markings here. This triangle here means because this one and this one are equal. They have the same markings, they are equal. So this side and this side are equal. So we call this side, this type of a triangle, isosceles. An isosceles triangle is a triangle that has 2 sides equal. Then we have the final one. We have the final, in terms of side length, you realize that they have the same markings through. The 3 sides of the triangle has the same markings, meaning all the 3 sides are equal. When we have a triangle whose sides, all the 3 sides are equal, we call that type of a triangle equilateral. Equilateral triangle. Equilateral triangle has all the 3 sides equal to each other. So from the side lengths, you realize that we have 3 types of triangle. We have a scalene triangle, which has no side equal to any other side. We have an isosceles triangle, where 2 sides are equal. And we have an equilateral triangle, whose all the 3 sides are equal. We can also have triangle being classified by the interior angles. What do you mean by interior angles? We are talking about the angles inside the triangle. This angle here, here, and this angle. So you realize that the same way a triangle has 3 sides, it also has 3 interior angles. So we have said interior angles are the angles inside the triangle, and there are normally 3 interior angles in a triangle. So we can have, depending on the size of the angle of the triangle, then we can have different types of triangles also. For example, We can have a triangle whose 3 sides are less than 90, all of them. The 3 sides, this side, and this side. All the 3 angles are less than 90. So you realize that this is less than 90, this is less, this is less. If that is the case, then this type of the triangle is called acute. Acute angled triangle. In other words, all the angles are acute. We said acute angles mean they are more than 0 degrees, but they are less than 90. So all the 3 angles are acute. So that is the first one. The other one is where we have one angle of the triangle equal to 90 degrees. It is a right angle. It has a right angle. So if it has a right angle, one side is right angle. Then this type of triangle is called right angle triangle. If it has one side equal to 90 degrees. You realize that this angle is more than 90. This triangle has one angle that is measuring more than 90 degrees. If that is the case, we said an angle that is measuring more than 90 degrees, but less than 180 is called obtuse. Then we will be able to call this triangle obtuse angled triangle. So those are the 3 types of triangles, depending on the angles, the size of their angles. So we have acute angle triangle, all the 3 sides are less than 90. You have right angle triangle, one side is measuring, one angle is measuring 90 degrees. Then we have obtuse angle triangle, meaning one angle is measuring more than 90 degrees but less than 180. The sum of interior angles of a triangle is 180 degrees. The sum of all the interior angles of a triangle is 180 degrees. So that if we have a triangle like this, then all the 3 angles should add up to 180 degrees. Should give us 180 degrees. So when we are given a right angle triangle, we already know one side, that is 90 degrees. Then we are supposed to find A and B, and A and B should also, plus 90 should give us 180 degrees. If it's not a right angle, even if it's not a right angle triangle, then angle A plus angle B plus angle C should give us 180 degrees. In other words, the sum of all the interior angles of a triangle should equal to 180 degrees. We're talking about the interior angles of a triangle. A plus 38 degrees plus 92 degrees should give us 180, and you should be able to give a reason why. So we have said the reason is because these are angle sum of the triangle. Angle sum of a triangle gives us 180 degrees. So if we add the 3 interior angles, they should be able to give us 180 degrees. If we add 38 and 92, That will give us 130. If we collect the like terms, we take 130 to this other side, we'll have A equal to 50 degrees. So the value of A is 50 degrees. So, and we are able to calculate the value of A because of this theorem here, that the angle sum of a triangle is equals to 180 degrees. So in our next lesson, we are going to look at more examples on this theorem here, that angle sum of a triangle is equals to 180 degrees. But for now, let us remind ourselves of what we have learned today. We have learned that when we have two lines and a transversal, then we can be able to obtain alternate angles which are equal to each other. We can also be able to obtain co-interior angles which are supplementary angles, and we are also able to obtain corresponding angles which are also equal to each other. So then you can be able to identify, given two lines and a transversal, whether the two lines are parallel or not, using the three concepts that we have just mentioned. Then we have also gone ahead to look at the triangle, and we have learned that the angle sum of a triangle is equal to 180 degrees. In other words, all the three interior angles of a triangle add up to 180 degrees. So now the next lesson, we'll continue to look more on examples on the triangle, but for now, that comes to the end of our lesson. Thank you.